welcome to our workshop series Kubernetes from Zero to Hero. Over the next 6 weeks, I will walk you through the basics of microservices and Docker, Kubernetes basics, Kubernetes security, the concepts of operators, and Istio mesh networking. See you every Wednesday afternoon, 2 p.m. Central European Time. Enjoy. Welcome to the Kubernetes workshop series. Today we'll be talking about Istio mesh networking, which is pretty important, or has become pretty important in the last few months or 1.5 years, let's say. For today, it's pretty simple. I will be talking about Istio, the mesh networking. That's one module, and then you can do the hands-on labs if you like. We'll talk about that in a second, but as you can download the VM on your local machine, you can do the labs whenever you like. It's completely self-contained and everything is in there. Okay, the videos are shared under this link. I think most of you know that already. On the very bottom, the source code for the labs is under the training repository, and on the Kubernetes training public, you will find the presentations, so PDF versions of the PowerPoints, and the lab documents, so that you can use either the VM with the web-based lab environment, or you can do that from the PDFs if you like. Let's rapidly talk about lab preparation. We had our session yesterday. We had 2 or 3 people dialing in who had some questions, but we were able to resolve those, so everybody should be okay, hopefully. So again, the VM contains everything you need for all the 6 installments, for all the 6 trainings. You have Docker pre-installed, you have Minikube for Kubernetes, you have some tools pre-installed for the security part mainly. You have your personal training environment that will start up, so basically the different tasks that you have to go through and so on and so forth. This VM will not expire, so you can use it even in September if you like to do that later. Probably for the September installment, so Euro already told you I'm working on some new material for September. So I'm targeting three subjects for the time being. One is multi-cloud management. So that will be a little bit more IBM-ish, if you like, because we'll be doing some exercises and some demos on IBM tools and IBM labs. Another one would be Kubernetes advanced concepts. So I would like to talk about init containers, about dynamic provisioning of storage, and so on and so forth. And the third one, that's the one I'm not 100% sure, but I see, is DevOps in a cloud-native world. So about Tekton and pipelines and stuff like that. So how do you automate your CI/CD pipeline in a cloud-native way? So I might be doing a new VM, a little slightly updated. I'm not sure about that yet, but we will let you know, and it will be clearly marked in the in Eventbrite if you have to download a new VM. But for the time being, you can use the one that you have. Okay, so for the setup, one important thing, and I pinned that in the Slack channel, for the ones who are using IBM Cloud or some other cloud, because they don't have a 16 gigs machine, obviously you won't have your personal training environment. So I set one up for everybody. So everybody will be using the same one, but that's not a problem. You can do that. It's just that you don't get your progress monitored. Okay, but you can go to this link that is pinned in Slack if you want to do it that way. So if you're using the VM again, if you have the software update, just say remind me later, because we don't need that. It will take some time. You can probably have to change the keyboard if you're not from Switzerland. You can do that in the upper right-hand corner. And then you have to start the terminal. We had a question before. Where can I find the terminal? So it's the little terminal icon on the left side down there. And then you'd have to type in welcome.sh. Probably most of you know that already, which will initialize everything. So your personal training environment, the network plugins, Minikube, Docker, and everything. So that will take some time. You can enter your name. I don't monitor that anymore. I took out the instructor dashboard, so we don't monitor anything. So you can put in whatever you like. I will update that in the future, so you don't have to put it in. It's just so that your training environment has a name on top. That's all. Troubleshooting, I guess we don't have to go into detail. Just know that on Windows 10 there's some conflicts with Hyper-V if it's running, so you have to turn that off to be using VMware or VirtualBox so that it runs. Okay. I've also created a standalone version, so you don't have to use the VM. You can download everything on your machine, but you must be pretty tech savvy because you have to have Minikube running, you have to have Docker running, you have to have Git installed and stuff like that. But if you want to do that, you can do that. There's a welcome.sh, a specific one on the training standalone that should set up whatever is needed if you have installed those components. But it's completely untested, so no guarantee it will work. But as far as I know, some people in the trainings have done it with success. Again, I'm always coming back to that. K9s is the absolute must-have tool if you're serious about Kubernetes. It's open source. You can download it. It's basically what we called Norton Commander back then for Kubernetes to edit resources, to delete resources, to view logs, to create a shell into a pod, and so on and so forth. So, good. Afterwards, once everything's completed, your personal training environment and the Kubernetes dashboard should come up. And then you can select the course. Today it will be JTC 10 Istio, and then you click on Begin Course. Then you go to the class, automatically to the class network tab, and you have a drop-down with all the different tasks that you can go through. But don't select them manually. Just really try to go through in sequence, otherwise you might miss something. Then just click Complete, press Mark Completed, and you go to the next task. And if you want, you can go to the Statistics tab to see how you're progressing. Again, that won't be working for the shared environment that I showed you before, that I pinned to Slack. Okay, questions. So I have some questions in Slack. So still waiting for personal training environment to reach running state. Yes, that can take some time. It has to download all the images and everything to run them. It can take some time. Just wait it out. It should come up. Provide the recording. Yes. Okay. Yeah. We will be talking about mesh a lot. No worries. I'll talk about that. How to execute that and connect it to Windows with PowerShell. I have to take a look. Oh yeah, I mean, if you want to use it on Windows, obviously you have to clone the training repository. Okay, so you do what I do in the standalone, the welcome.sh. So I have to do a git clone of the training repository. Let me just go back to the URL a second. Where is it? Here, to the one on the bottom. So you have to do a git clone, https github, blah blah blah, equals hit training. Like that, there you have all the different elements in there. Otherwise, obviously, the training issue samples, blah, 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 won't work. That's for sure. So you have a problem, line 72, Minikube command not found. What environment are you in, Apia Corel? Are you in the VM? Think so, huh? So, but if you can be a little bit more precise and perhaps put in a screenshot or something like that, we can try to help you. Okay, so let me go through that and let me start. Okay, you're Ubuntu local. Yes, I mean, if you're Ubuntu local, did you install Minikube? You need to have Minikube, otherwise it won't work. So you need Minikube installed, not Docker. Do you need Docker for this one? It's always a good idea to have it. I don't think we might need it, but you need to have Minikube installed and Git installed and all that stuff. Otherwise, it won't be working. Okay, I'll have a look afterwards if you have something more. So let me hit it off with a short introduction to this mesh networking thing. So when we talked about containers and microservices, I told you, and you've seen that we can deliver much faster. So we improve delivery velocity with microservices, and in the end with containers and Kubernetes, because there are small teams that can develop at their speed. Some can deliver every day or several times a day. Some can deliver like once a week. It doesn't matter. So you decouple all those different dependencies from one functional element to another one. So improved delivery velocity, it's pretty stable and whatever. It's really, I mean, you've seen that's a pretty cool solution. But we get a hugely increased operational complexity. So if you have a look at a typical graph on how the services talk to each other, it really gets hairy and very, very, very complicated. So with that, and I want to perhaps before diving in here, I want to shed a light on mesh networking in Istio a little bit more from the DevOps, from the developer and operations side. So to see what challenges, what everyday continuous delivery challenges a mesh network can solve. That's the idea. So the first challenge that we have in DevOps in that case is, how do I roll out a new version of my microservice without any downtime? So obviously Kubernetes has some mechanisms for that, with the Kubernetes create, rollout, and rollback and stuff like that. You can do that, but it's still pretty basic. So as we will see, mesh networks, and in specific Istio can help with that, like start rolling out a new version. How can I ensure that my traffic continues to go to the current version that has been working for a week now or for a month now, before the new version is tested and ready? How can I do that? Testing them to one besides another. Another challenge is the famous canary testing. I don't know if I should have to make a poll for that. Does everybody know what canary testing is? So canary testing basically is putting a toe in the water and see if you will go for a swim or not. Sorry, I have a pop up here. Okay, so so the idea is to be able to say, okay, I have my V1 and I have my V2 of my microservice. Now let's just start sending 1 or 2% of the traffic to my version 2 of my microservice and see if it flies. And the word canary testing, by the way, it's not a joke. That comes from the miners back then. They went down into the mines, and sometimes you had gases where you couldn't breathe anymore or whatever. So they took real actual canaries with them, and if the canary fell over, they ran out of the mine. So that's where the name comes from. So it's really about putting a toe in the water, putting the canary first and see if it rolls over and die, to be able to see if something in a very small percentage of deployment will fly or not. Okay, and how can I do the full rollout afterwards? If my canary testing has succeeded, if I see that everything works, how can I do the rollout? The next challenge is A/B testing. So really a subset, for example, to roll out my version 2 for a specific subset of users, for testers, for example. Or I want the new version to be rolled out to Android users and have the iPhone users still on the V1, or the other way around, doesn't matter for that matter. How can I test the new version with a subset of users? How can I say, in that case, testers, or how can I say all users in North America are going to the new version, stuff like that. Other challenges are obviously things don't always go correctly in production. How can I prepare for that? How can I inject fault to my microservices in the testing phase to be prepared if something doesn't work? Like, for example, if a service takes like 15 seconds to answer a request, or what happens if I get corrupted XML or JSON files back, stuff like that. The fifth one is what we call rate limiting. So I have a service has been containerized, but it's still a little bit old worldly. and can only handle, let's say, for example, 20 requests a second. How can I limit that? How can I make sure that my service, my instance, my microservice doesn't get more than that? That's the idea. Afterwards, we have the view and monitor. How can I understand how traffic flows into, through, and out of my cluster? That's very complicated if you're using just the normal Kubernetes technologies. And then the last one, how can I secure my services? We're talking about that. Remember, I talked about securing the Kubernetes API with authentication and authorization. And here we're going to talk about how can I secure my workloads from the outside with authentication and authorization. Good. Okay, so what is a service mesh? Well, in terms of very technical terms, it's what we call a dedicated infrastructure layer. So that comes on top of Kubernetes that should make service-to-service communications fast, safe, and reliable. That's a mission statement, obviously. So service-to-service in that case would be pod-to-pod, microservice-to-microservice. But it's really something that we add to Kubernetes to improve stability, security, and so on of the communication between those elements. Enter Istio. So Istio was launched in May 2017 by Google, Lyft, and IBM. So we were in there. We donated quite a big chunk of code to the project. Lyft, they donated the proxy. We'll be talking about that, and Google all the rest. So the cool thing is it's completely open source, and you need 0 code changes to make it work. So you install that into your cluster, and from then on you can use Istio and the advantages of Istio without having to change your code, your microservices. Sorry. So that's probably the most important thing. So you can deploy an Istio mesh network, use it or not. You can choose where and how to use it, and you can use it without changing your existing microservices. So that's the really cool thing about that. So we talked about that already shortly in one of the last installments. So how does the whole thing work? So if I have 2 pods, I have a service A, service B, with the container that's running, first one service A, and the second container running in the other pod called service B. So first what we do is we define the mesh boundary. So that's where does my mesh start, where does it stop? Very often that's the cluster itself, okay? And then we get an ingress gateway and an egress, so outgoing traffic gateway. So that's where the traffic comes into the mesh network, and the egress is where it flows out. So those are envoy proxies. Those envoy proxies, as I said, have been donated by Lyft. They're very lightweight and very powerful proxies. And they're starting to be seen like HA proxy or Nginx. Those are the 3 major proxies that we're using today. Istio project has made the choice for Envoy because it's really extremely lightweight and doesn't add much to the workload. So what happens afterwards is that when I installed Istio into my cluster, every new pod that I'm starting will get an Envoy, a proxy sidecar. Remember, we talked about that in the Kubernetes installment in the second course, that you should never ever put 2 containers in a pod, except for certain patterns, one of which is the ambassador patterns. What we globally call them sidecar patterns, because it's like this is the motorcycle and that's the sidecar of the motorcycle. So it's just in very specific cases that you should put 2 containers in a pod. So what's happening here is as soon as I start a pod, this Envoy proxy gets added to the pod automatically. Remember from one of the last courses with different states when you create a pod, for example. So you go into the API, the Kubernetes API, you send your YAML in. It will go through authentication, authorization, and so on and so forth. And at a certain stage, if you remember, we have this mutation webhook. I don't know if you remember. So that's one stage where before deploying anything or creating anything, Kubernetes checks if the stuff that's coming in has to be modified. The YAML itself has to be modified in some shape or form. So what happens, simply put, is you create your pod. This webhook says, okay, it goes into this into the default namespace, for example. In the default namespace, I want to use Istio, and it automatically completes or augments the YAML file with the Envoy proxy and then sends it into etcd, and it gets deployed through the controllers and the schedules and whatnot. So that's completely automated through this webhook. You can do that manually as well if you don't have webhooks, but normally today we have webhooks in virtually all Kubernetes environments that I can think of. So again, we have an Envoy proxy for the ingress gateway, Envoy proxy for the egress gateway for the outgoing traffic, and then one Envoy proxy for each pod. Now, when traffic comes in, flows through, so it comes through the ingress gateway into the mesh, and then is sent, if you like, and that's why it's called a mesh, to all. Here it seems linear, but it's sent to all the Envoy proxies. So every Envoy proxy gets a copy, if you like, of this traffic, and decides afterwards if this traffic, this traffic should be sent to the payload, so the service itself, to the container itself or not. Okay? So now how does this Envoy decide that? So we have what you call the control plane. And it has slightly changed now, but the elements are still more or less the same. So we have one thing that's called the pilot. So this one is responsible for service discovery, the rules, traffic and routing rules, and authentication. This pilot sends this data to all the envoys in the mesh. So the pilot has the configuration and sends this configuration to all the Envoy proxies so that they know if they have to respond to certain type of traffic flowing through the mesh or not. The second one is Mixer, which is logging, telemetry, quota, control, and authorization in that case. So this has been greatly optimized because in some later versions, like a year ago, an Envoy proxy, each time there was traffic flowing through, reported back to Mixer. So they were in constant chat mode, if you like, and that slowed things down quite a lot. So they changed the architecture a first time to have this this whole mechanism a little bit less chatty. And now you will see that when you install it, they completely changed the way you install Istio. Now you can just install it with one command, and there's just one daemon running called Istio-D that contains all of those elements. So they went the other way. They went from a microservice architecture to a more monolithic architecture. But in this case, it was necessary to have the performance that we expect from that. But the elements are still more or less the same. And the last one was called Citadel. It's for certification and key management. So that's the TLS certs that are sent to the different proxies so that they can communicate in an encrypted way inside the mesh if you enable that. We will talk about that in a second. So that's basically Istio. So if you understood that, you can drop out. Traffic coming in, flowing through the mesh, through all the Envoy proxies, and each and every Envoy proxy decides on what it has to do with this traffic, if it has to send it to the pod that's in the same to the container that's in the same pod or not. So that's Istio on a very high level, view. So Istio operates at layer 7, so which is the application level. So the cool thing about that, and you will see that in a second, and you will experience it in the labs, is that we can have policies like traffic routing policies based on virtual hosts, URLs, or HTTP headers, for example. So if you have a header for a user that's logged in, you can use that to route traffic to a service. Okay, so it's very flexible, and it allows it to be distributed, and that's very, very important point. So Istio can be distributed, and it can even be distributed across different clusters. It's not that simple, but it's doable. So you could have an Istio mesh that spreads over several or federates several clusters. So it's doable, and it's getting easier and easier from one release to the next. Okay, I'm looking at questions. It is working. Perfect, Eduardo. Good. Okay. So what is usually used for communication between services, REST or gRPC? Yes, good. That's going down the rabbit hole. Thank you for that question. How to move between nodes in my current app using Karaf. Okay, so OSGI with Karaf, I don't know this one. But for REST against gRCP, I'm not the big specialist on gRPC, but gRCP is much more robust. So it's starting to get a pretty big foothold for communications between the services in your cluster, in your mesh, because it has some properties like the famous ACID properties that guarantee delivery and stuff like that you don't have with the rest. Okay, so that's one thing. And the second one, if I understood well, is that gRPC can be used with any protocol well, basically it's remote. It's a remote procedure call, so it's not based on sending around a certain format like JSON or YAML or XML or whatever, but it's like you would be calling a local stub of your remote procedure. So with that, you can call whatever you like. You can call C functions, you can call Node.js stuff. It doesn't matter. So it's a bit more flexible. It's more robust, and Google are using that. Obviously, that's why, hence the G. Because the standard REST calls cannot scale to a level that Google needs, for example. So I cannot tell you more for the time being, but gRPC is picking up a lot of speed lately. So if you can implement it in gRCP, it's probably a good idea, especially if it's services that have that rely on guaranteed delivery and stuff like that. Then the second question, if I have an app to be converted to microservice separated in layers, let's say REST layer, business rules, data transfer objects, persistent layer, how to move between those layers? I'm not sure if I get the question now. Obviously, when you split up an application to microservices, you don't really get layers. I mean, you get microservices, and each microservice is running besides another one. But what's often done is that you have a microservice that abstracts away an underlying set of microservices. So let's say, for example, you have a microservice to book a flight. So you would have a microservice book flight, and this book flight microservice would then call seat availability, ticket issuing, and stuff like that. So try to separate them and spread them out a little bit. But pay attention as well, and we talked about that, I think, in the first installment, to not have too many hops, because each call, be it REST or gRCP, has some cost in latency. So if you do sequences where you have like 5-6 levels of calls going down to microservice, you probably lose some performance. But usually it's good idea to have some more high-level microservices that expose APIs, perhaps also to the outside world. That those will be the ones that might have public-facing APIs, and then from there on you call the nitty-gritty really small microservices that do the actual work, and those afterwards can talk through gRPC, for example. Okay. And again, as we've seen in the second training, those microservices will by default be completely isolated from the outside world. So no one will be able to go into them unless you expose them through services. So usually it's a good idea to have some sort of, I guess that's what if you say REST layer, that would be an API layer. Sometimes it's a good idea to have an API management tool as well to secure those APIs a little bit further, to have usage tracking, stuff like that. And then from those high level, be it REST layer or API layer or whatever we call it, then go down into the more low level stuff that does the actual work. What's the use case of the Envoy pod? As I said, it's just a proxy. Okay, so Envoy, as I said, is used for the ingress egress. So if you want to go or access stuff in a cluster, you need an ingress and you need a proxy through which you can access the inside, because your cluster has usually just one public facing IP address, and then from this IP address we must distribute the traffic to the running microservices in the cluster. So you need, in some shape or form, you need an ingress controller, which is a proxy, which can be done by Envoy or Nginx or HA proxy. I think OpenShift uses HA proxy. At IBM, we use Nginx, and Istio uses Envoy. But that's 99% of the time. That's completely hidden from you, and you don't have to think about that. Okay. Good. Now that we have settled that, so we have our ingress. So traffic will come in through this ingress, okay, through ingress control through this Envoy proxy. Now the first type of kind of object that we have to create is what we call the gateway. That's really the most outside thing that we can define. And what we're doing here. It configures the ports that we will expose. It matches those ports to a destination. We'll see that in a second. And it's attached to this Istio ingress control. So the Envoy ingress control. Okay. So what you have to do is create a Kubernetes object of kind gateway. So that's obviously, and you probably know that by now, there's no such standard Kubernetes object called the gateway. So we are using CRDs, custom resource definitions here, to create our own specific YAML definitions. So that's everything is installed. You will see that in the labs when you install Istio. So we create the Kubernetes object called gateway, give it a name. Very important, you have to put that in here. Select Istio ingress gateway. That's the one that binds it to the Istio ingress control. If you don't do that, you won't be able to catch the traffic. You could use others. You can use HA proxy. You can use Nginx. There's examples of that on the Istio webpage. But for the sake of argument and for simplicity, we use the standard Istio ingress controller, which most of the people do, by the way. Okay, good. Then we define our servers. So first we define a host. For example, myapp.demo.com. And we say on that URL, we have the port 80 that's open for the HTTP protocol. Simple enough. What's important is that this myapp.demo.com has to resolve from the outside to the IP address of the cluster and the ingress gateway. So you need some sort of external, it doesn't matter, DNS server that can resolve this IP address. Otherwise, it won't work. So what will happen is that when you call myapp.demo.com, it will get routed to the ingress gateway. The ingress gateway will see that we called this URL with this host name, and it will know that this traffic has to be routed through this gateway. So that's just the endpoint where traffic comes in. Other questions? No. Okay. We will see it a little bit more into detail afterwards. Well, in detail, no, in a more overview way, so that you have an idea. So let's start with a simple example. We have a pod called Hello World, has a label version equals v1. Very nice. Then we have a service defined that has a selector app Hello World, so it points to the pod. So that's what we've been doing until today. So you can define, for example, this service as a node port. You can export that, absolutely no problem. We do business as usual. Now, we define our gateway, as we've seen before, with myapp.demo.com, port number 80, HTTP protocol. So for the time being, that doesn't do anything. So if someone from the outside opens this web page, so HTTP port 80, this address will get routed or should get routed through the DNS to the gateway, to the ingress gateway, and for the time being, it stops there. This gateway says, oh yeah, that's for me, but I don't know what to do with it. Now, the next thing will be what we call the virtual services, and that's probably the most important element in the whole Istio thing. So, virtual service, again, it's a YAML file with a kind virtual service with a name. You put in the host again. You tell it which gateway it's linked to, so the gateway that you just created. Then you can start doing some magic stuff with the traffic. So we say, okay, for HTTP, if it matches the URI/demo, route it to the destination host hello world. Now, let's have a look at that. So we link those two together with the gateways instruction here. And then the host hello world points to the name of the service. Now, you remember what we discussed in episode 2. A service, you can address a service or a pod through the service just by giving it the service name hello world. This works only if you're in the same namespace. If you're in another namespace, you will have to put in hello world dot and then the name of the namespace where the service is situated. Keep that in mind, it's very important. So the host just points to the host name, which is, in this case, hello world, because it will be in the same namespace. And it will route it through the cluster internal Kubernetes DNS. Because you remember, perhaps for the ones who haven't participated in the second course, when you create the service on a pod, it automatically creates an entry in the Kubernetes DNS, in the cluster DNS, that says, okay, hello world points to the IP address of this pod. But as this pod can have a different IP address each time it restarts, that wouldn't be practical. So we have a DNS entry through this service definition that will get updated and always point to the pods that are running. Okay, so now, if this guy goes in, says http myappdemo.com/demo, myappdemo.com resolves to the Istio ingress. The gateway says, okay, I have myappdemo.com. That's for me, and it's on port 80. Okay, that's for me. And then the virtual service says, okay, I got something from Hello World Gateway, and it does match /demo, so route the traffic to the service. And that's it. As simple as that. Now, this is not game-changing up to here. Okay, so if you see that's just an ingress configuration, that's basically URL routing. We could do that differently with classical Kubernetes ingresses and stuff like that. Now, where it gets interesting is with what we call the destination rule. So a destination rule, you can have what we call subsets. So what we do here, we say we have a subset that's called V1, so an Istio type subset, which has a selector which goes on all the services that have labels all the pods that have version V1. Then we have a V2 that's version V2. Okay, and in addition to that, through the destination rule, we can also say traffic policy. In that case, it would be TLS simple and the connection pool and blah blah blah. So we can define TLS termination here at the pod level. Okay, now let's put it into context. So I have a new pod here, V2, still hello world. So my service points to both of them. That's very important. And then I have the destination rules with the labels that are pointing to the two different pods. So now what I can do is I can say, okay, I add the second destination, again, host hello world. And now I can say this destination is subset 1 and subset V2. Obviously, you could use another host, or you could create a second service for another pod. That could work as well. So you're completely free to use the host that you want. But in this case, we're really wanting to split traffic and to roll out traffic across those two versions. So what we're doing now afterwards for the whole canary testing thing that I've been talking about, we add a weight. So I say V1 has a weight of 90% and V2 has a weight of 10%. This has to be 100%, the sum of those. Well, you can have 3 or 4, you can have more destinations, but the sum of all those weights must be 100%, otherwise it's very unhappy and won't create it. Okay, so what happens here, is that when I call this URL, 9 out of 10 times, I will still get the traffic from version 1. And 1 out of 10, I will get the response from the V2. So that's an extremely interesting means to do gradual rollouts and putting the toe in the water canary testing. So you can say, for example, I have a new version V2, I deploy it. That's what we've seen here on the right. Define destination rule, and then I can start rolling out traffic very slowly, perhaps just 1 or 2% in the beginning. So your end users who are using your application through the same URL, that's completely transparent. 1 or 2% of those will start hitting the version 2 and start working with the version 2. And then if there's no complaints after several minutes, you can start rolling out 5% and 10% and 25% and so on and so forth, until you get to 100%. That's what we call canary testing or gradual rollout. So this is also a feature, and I probably shouldn't be saying this, but it's a reality. It's a feature that helps you roll out new versions that have been less thoroughly tested than you would have liked it. And the reality is that we never ever have enough time to test new releases. I see that at almost all my customers. They never have time enough to completely test the new releases and to test everything they would have liked. So this is, as I said, a possibility to roll out something, to roll out faster with versions that are perhaps a little bit less tested, but that have less feature changes in them as well. So I just do a little change, start rolling it out through this mechanism, see if it flies, if your support hotline blows up or not. If it doesn't, you can roll out to 100%, and that's it. And then you keep the V1 around perhaps for a day or two to make sure that if you have to roll back, you just go to 100% and 0%, so you can easily roll back, and it's done. Now, there's one thing, and I'm pretty surprised that no one mentioned that in Slack yet. When you have database changes as well. So if you go from V1 to V2 and the database changes, then it gets obviously much more complicated with roll forward, roll backs. But that's a topic for another discussion. And in 99% or 95% of the cases, you don't have that, because as you're using microservices, you abstract that away normally. So just keep in mind, it's an absolute fabulous means to accelerate delivery, to secure delivery, to make it more robust, more controllable. But in certain specific cases, it can be dangerous because you cannot roll back afterwards. Okay? Good. Why do I still have this? Okay, I should have taken that out. Okay, no, it's for this. I should have taken the animation out. Another cool thing that you can do as well, which is fun, is, for example, you can match headers. So we only matched URIs here in the first example. So here we can match headers. For example, you can say, if I have a header end user, which is Jason, send him to V2, otherwise send them to V1. So like that, if Jason is logged in, he will be using V2, so he can test, for example, the V2, and all the other customers, existing customers and everybody else still using V1. So that's one of the possibilities to do dark launches or gradual rollouts or very targeted A/B testing and stuff like that. Okay? So I have a question. Can I have an app in your case, Hello World, with two different versions where when one has a feature with button blue and the other with button red? Yes, you can. And that's exactly the thing. And you will see in the labs, there's a pretty neat demo app for Istio, which we'll be using, which is called Book Info, which has, I think the first one is, it's a product page. Then you have, it will go out and get the details about the books, and then it will go out and get ratings, I guess, or reviews. And then you have different review services, and you will see in some cases, I think V1 you don't get any stars, in V2 you get black stars, and in V3 you get red stars. And we will be playing with that, with the different mechanisms, with the different matches and so on and so forth, to show you how you can do those gradual rollouts and so on and so forth. And you will see sometimes Depending on the case afterwards on the lab, you will get black stars, you will get red stars, and so on and so forth. And the cool thing about this application, this bookend4, is also that it has been developed in, I don't know how many different languages. You have one microservice in Python, I guess, one in Node.js. I don't remember. I'd have to look it up. But it's pretty cool to mess around and get your hands dirty without killing your production environment. Cool, good. One word about sidecar injection, just to wrap this one. So you can do manual injection. So we have this command line tool called Istio control that you will be using to install Istio, for example, as well. So if you want to do manual injection on a deployment, usually we would do kube control apply -f and then myapp.yaml. That's the standard classic way. Here, what we do is we say Istio control kube inject -f myapp. So it takes the myapp YAML, adds all the sidecar things, creates a new YAML file, and then we pipe it back into kube control apply. Sorry. So it does exactly the same thing that the webhook does as well. Okay, just manually. So I just wanted to show you this so that you have seen it once. Usually you don't need that anymore, but you can do that. For automated injection, so it's this famous mutating admission webhooks that I've been talking about before. You have to put this annotation, this label, onto each namespace where you want to use Istio injection, auto injection. So we will see, for example, in the how you say in the lab, we will use default namespace. So we will add Istio injection enabled to the default namespace, so that everything that gets deployed into the default namespace becomes automatically part of the mesh network through this automatic injection. Okay. So just for information, if you want to have a look, you can do kube control get namespaces or NS, it's the same. Then -- show labels if you want to see the labels. Okay, and then a last way to do that, to not do injections, is you can do an annotation on a deployment, say inject false, in which case it won't do the injection. Like that, you can avoid that. If you have one very specific part in a namespace that usually you have automated injection enabled, and you don't want this one part to have that enabled, just put in this annotation. You'll probably never use that, but just for completeness that you have it. Okay, so before going into the challenges again and going through all of those, this is a good example. Where can we update a service and not having to restart something like an application service? Exactly. Yeah, perhaps I wasn't very clear enough with that. Thank you for this remark. Very useful for heavy traffic apps. Absolutely. So up until now, when you had to reroute traffic to a new application, a new version, new something, usually you have to change routing tables or routings and proxies and stuff like that. And very often we have downtime with that. With Istio, we can ensure that everything goes smoothly and that we have absolutely no problem with that. Is that always the same Hello World release? No, we have two Hello World releases in that case. We have version 1 and version 2. It's just the same service in that example. And the service has the selector to app name Hello World, so it's pointing to the two of them, which in itself in Kubernetes doesn't make sense, but in the case of Istio it does make sense. Okay, let me just walk you through the different. Oh no! Hey, break. Yuri, do we break?
Yes, perfect.
Okay, so
you have to interrupt.
It's 5 past. Let 5 minutes should be okay. I listed here the different challenges again. So for each of the challenge with this is the solutions that we have in Istio, and I would like to walk you through the different elements rapidly now. So the first one is traffic control. So rolling out a new version without downtime or changing code. So that's what we had in the Slack channel rapidly discussed before. So I have a version 1.5 in production, for example, and I want to start rolling out to version 2.0 in US prod in the environment. So I'm starting with my route, virtual service, 100% traffic goes to version 1.5. Now here we're talking really about 0 and 100% really switching over. It's not about canary and gradual rollout. So what you simply do is you update your virtual service to point to version v2.0 with the weight 100 and the traffic goes over there. So that's this rollout in one step from one version to the next one in a 100% split. So I'm not sure if that's what you want to do. I probably go for canary deployment, so gradually roll out the whole thing, but that's one possibility that you have. Then obviously we have the traffic splitting. That's the one I talked about, where you can say, okay, I'm routing 5% to an alpha version in the staging environment, and check what how it goes, if it flies or not. So that's what we call traffic splitting compared to traffic control in the first example. Then we have traffic steering. That's where I can say, okay, if I have a match with the HTTP headers, if the user agent is something iPhone, send it to the version v2. Well, we could invert that with Android, it doesn't matter. But it's just reacting to information that you have in your headers, be it based on user agents or logged in users or whatever. You can say, I send a part of my traffic to the new version for a specific role, for a specific kind of user agent and whatever. Okay. Example for it could be if you have a problem with a web page in Firefox and it displayed correctly in Safari and Chrome and all the others. You could do a patch, for example, and send the Firefox traffic to the new version to test it out and see if it works, and then switch completely over. Then, very interesting thing, and that's the last lab that you will be doing today, if we have time enough, hopefully, is traffic mirroring. So one thing that we said is that in production or in testing, often not everything goes right. So if you would like to check your development version or your test environment with real production traffic, you can do that with the mirroring. So you can define your virtual service. So we have the standard one where the 100% goes to the production 1.5 version. And then we can add a second one and say, okay, for the alpha version or staging or whatever test version, we have a weight 0. So no traffic itself is sent to this service, but we mirror the whole thing. So that means that we get the exact copy of the traffic that flows into the production version. We get that into the test version. So obviously it's what we call fire and forget. So you won't get any response back or anything. You just get the traffic and can act on this traffic. But that's a very nice way of doing real life tests by just splitting off 100% of your production traffic and sending it into a test environment. It's like a bit, if you remember the Prism scandal in the US, where they just split the traffic and sent the copy of all the traffic into NSA or whatever locals. So you can do the same, but in that case it will be for testing. So that's a very cool feature, and as I said, you will be doing that in the lab. It's the last lab of the whole lab series. Then I won't go too much into detail here, but one is resiliency. As we said, not everything goes correctly in production, so we can use things like circuit breakers. I don't know if you're familiar with that, or health checks and stuff like that, where you can say, okay, if some downstream service, if some upstream, so a calling service is not behaving, if it's starting to do stupid things and sending a lot of packets or something like that, we can hence the circuit breaker term. So the idea here is that we can reduce the blast radius of one microservice starting to act up. So you have perhaps the review service, as an example in the bookshop, it will just cut this connection for a certain amount of time, so that you can take action and correct the problem with the service that's not running correctly, instead of going of your whole production system going down. Obviously, you will have you will lose some functionality. For example, you won't get the red stars or stuff like that for the time that you correct that. But you really limit the blast radius of a problem with one microservice. So that's that. Then oh, sorry, I have some examples. Okay, I won't go too much into detail, but it would be defined in the destination rule. So what you can say, we limit to one concurrent connection, one request per connection. So that's the green stuff, max connections, max pending requests, and so on and so forth. And then we can detect what we call the outliers. So we can say, when do we eject the whole thing, the call? So if we have 2 consecutive errors within 2 seconds, the review service in that case, that one here, the host, will be ejected for 3 minutes. So that helps us to cut this this connection with the review service, so that we can take action. So that's one example. Another thing is fault injection. I've been talking rapidly about. So how can I test? Not talking about the mirroring. Mirroring is one thing, but how can I test and make my services more resilient? It's pretty complicated to inject fault into a running system without bringing the system itself down. So if you want to test that very safely, you can say, okay, I match all the headers for a user that's called bar, that's logged in. So all the requests that are coming from bar will have a 2-second timeout. You can see that here. So if bar is logged in and the sequence of calls comes to the rating service and the user is bar, we do automatically a 2-second timeout. 2 seconds is obviously not very high. We'll put in like 15 seconds or 30 seconds to see how the calling service is reacting. So if my calling service that's calling ratings has some logic in there that's not able to handle very long delays, if the rating service has a problem, we would detect it here. And in addition to that, we will say 40% of all the requests also have a 5-second delay. So you can do a lot of stuff in here. I don't want to go into detail. It's pretty complex stuff, but there's very good documentation again on the Istio websites with some examples that I used here. Another example is if I have my end user foo. So 20% of the requests from foo get the 500 error. Okay, you can see that here. So if the user is foo, we abort the thing on 20% of the calls and give back HTTP status 500. And all the other requests, just for good manners, we add a 4-second timeout. So like that, you can really, just through a simple virtual service definition, you can start testing the resiliency and the robustness of your microservice application. Another one is rate limiting. As I said, if I have microservices that have some limits in how many requests they can take per second, with that you can create what we call quotas and say, okay, I don't want more than so and so quantity of calls per second. The other way of reacting to that would be horizontal scaling. So you can add more instances of the microservice. So if you have just one pod, for example, that can take 10 calls per second, you could add 2 more. Like that, you should, in theory, be able to answer 30 calls a second. But that doesn't always work. I mean, it works if you have really well-designed microservices with the 12 factors applied and everything. But in reality, you often have microservices that have been packaged but mainly not optimized for the scaling, because you have a database in the backend that cannot scale and whatever. So it can be a good idea to use rate limiting if you see that that your microservice get to the limit. One example is if we have for the last valid duration, so it would be for 1 second. If it exceeds the max amount, so 500, well, in that case, it's the mixer that handles that. The mixer component in the control plane returns a resource exhausted message to the proxy. And you can go even further. You can define really for specific destinations and so on and so forth. For you can say, if the call goes to product page and it comes from this IP address, for example, then limit it to 99 calls and so on and so forth. So again, pretty complex stuff, but if you some challenges like that, I mean, it's something that's built into Kubernetes and which helps a lot to do that. Okay, so you have some explanations here more in detail. Good. Before I go into telemetry, let me check the questions. Eduardo, do exist something like queues in Kubernetes we have to implement in our course? It's not a queuing solution, so it won't be queuing your requests. So if you go over the rate or something, you just get a classic HTTP error back. So it doesn't do that. If you want to do queuing, in which case, I mean, queuing usually use that when you have asynchronous calls. When you do synchronous calls, you would be using REST interfaces, or you would be using gRCP or something like that. And if you get an error back there, you know that you have a problem. Either your backend services cannot take the load, in which case you have to find a solution to that. Either scale them, do automatic scaling, for example. You can do that as well. We talked about that in the second installment. You can create automatic horizontal autoscalers. That's just when you go over a certain time of response or something, it will start scaling out the pods. Or you have to have a look at your architecture, which might be flawed from the get-go. Where we use queuing is more in asynchronous calls, so that you have queues like MQ or MQTT or something like that, where the calling microservices puts its request, which will get consumed by the responding microservice. Then the responding microservice posts the response back on the queue to be consumed by the calling one. So this is used very often in finance environments, in banking and stuff like that, where you have an enormous amount of messages flowing through the system, and you want to have a centralized, let's say, layer that handles this communication, if you like. It's really complicated to answer it if you use one or the other. It really depends on what you want to achieve and how you want to decouple your microservices. Standard normal way through APIs, REST or gRCP. If you have a specific use case, as I said, asynchronous calls, for example, then use queues. In which case, obviously, the calls will be queued, and you won't have those problems with getting 500s or 404s or stuff like that. Good. Let's talk about how you can get a view into your cluster. So as I said, in a classic Kubernetes cluster, I don't know of any tool that draws you the schema exactly of existing applications, shows you this one is calling this one and that one, and traffic flows like that. There are some things in the what was it called, in Red Hat's advanced cluster management and in our IBM solutions as well, where you can discover some structure, but it doesn't give you what I'm going to show you in a second. So obviously the first part to that is the whole monitoring thing. So here you can have a built-in Grafana dashboard with Prometheus in the backend, so you can have a look at how your network performs, how many requests you have per second, and so on and so forth. How much is the load on the different elements, the pilot, the mixer, and so on the net. You can detect if you get to near 100% CPU usage, for example, stuff like that. So that's really a first view, a very technical view into what's happening in your cluster from a performance perspective. So if I can say, Then the next one, and that you will be playing quite a lot with, and probably also after the labs, if you go on. Is a tool that has been developed in the beginning. I think it was Red Hat. It's open sourced, and it gives you a complete overview on what is happening in your cluster. So you can have the graphs here, which is the most sexy part, and you will see those screenshots are from an older version. It's much more clean now and better to understand. So you can see here we have the famous product page. So that's, you will see that's where the traffic comes in through the ingress. And then we have the review service. We have the details that gives back the details about the books and so on. So those here are the workloads that are running. So the pods with the sidecar, and the triangles are the virtual services. So you can see how they depend on each other. You can see we have 3 versions of reviews, which you will be using afterwards. So the review service points to the 3 of them, and then you can use the virtual services to be in different ways. So you will see a lot of that, and you will see also, you see the small points now. You will see the traffic flowing graphically to one service or another. You see the percentages of the traffic that's going to a certain service and so on. And if one of those services starts acting up, not responding anymore, it turns red. So you can pinpoint where your problems lie. You can drill down. You can modify all the different YAML files that are part of Istio, like the gateways, the virtual services, the destination rules, and so on and so forth. You can modify them here in services and workloads and so on and so forth. So together with K9s, it's probably one of my most favorite tools in the Kubernetes world, because it really gives you a graphical insight in how is my traffic flowing through my cluster. Who calls whom, in which percentage, where does the traffic go? Do I have some problems? You can see it here. For example, it's getting red, so I have 501s from the review service, and so on and so forth. So it's absolutely incredibly powerful and open source tool that you can use to debug your mesh network. Security. Okay, so we have 2 parts to that: authentication and authorization. So authentication is transport authentication. So it's about encrypting traffic that's flowing from one service to another one. So we talk about that in detail in a second. Then we have authorization, where we can authorize a certain role, person, or whatever actor to access a service or not. So for the authentication, so if you don't do anything, your traffic flows through the different namespaces, through the different elements. So here I have 2 pods, HTTP bin with the envoy proxy, that's this little sign here. And I have a legacy pod that has no sidecar, okay? Because one thing that's important to know, when you install Istio, it won't add those sidecars to whatever has already been deployed. So if you want the sidecars in your pods, you have to scratch the deployment and recreate it so that it can add the sidecars to your pods. So now we have 2 namespaces, foo and bar, 2 Istio instrumented pods with sidecars, and an older one that only has a service and no sidecar. So if I don't do anything, they all can talk to each other, which can be interesting, and they talk to each other in a non-encrypted way, just over HTTP or whatever. Now, again, in the destination rule, I can specify you, and we have seen that rapidly in the beginning. I can say, how do I encrypt all traffic? So I can say for all the hosts that are star.local, remember the fully qualified name of the services, service name, namespace, and service something.local. So I say for all my services in my cluster, I have traffic policy, transport layer security, TLS, encryption, and mode is Istio mutual. So that means that it's only between Istio components. So that means now my Istio instrumented pods can talk to each other. They talk to each other encrypted over TLS, but I have no communication with the legacy stuff. So if it's not instrumented, it's basically invisible to the Istio paths. That's why it's called Istio mutual. So it's just between the Istio elements. You can do other stuff. You can say, for example, for this host after this HTTP bin legacy service class to local, I disable TLS. So that means that my internal traffic, because of this definition, Istio mutual, is still encrypted, but I can talk to this legacy service, but it won't be encrypted. Okay, so that's the simplest way to integrate, let's say, Istio external elements that are not part of this Istio mesh, that are not within the Istio mesh boundary. There's other possibilities. So you have some elements here with role-based access. You can say, if you say on with inclusion, that means enabled for all services that you specify. If you say exclusion, it's enabled for everything except the ones that you specify, and so on and so forth. I think you get the idea. So on with inclusion, so I'm saying I just want for those 3 services, I want RBAC enabled. So for the web app service, front-end service, and feedback service in the default namespace. Then you can go further. You can say for those services, for example, for get and head, so those are the HTTP operations, for all the paths, I want to apply those constraints. So for example, I can say, if the request header is version 1 or 2, I let it through, otherwise I won't let it through. So we can do stuff like that to really secure how they talk to each other, and say, for example, one microservice could be called only by V2, so you just throw out this V1. So you can do stuff like that. Another one, and now it's getting interesting, is when you say the services in namespace default, that's source namespace default, are only accessible by authenticated users. So that's here, the source principal star means I need for every source, I need a principal, and the principal can be a Java web token or something like that. And you will be doing, I've added that end of last week to the labs, you will be doing some stuff in there to secure services, and you will see how that works and how we can pass on this token and how we can secure the services in real life. Good. Questions? No, there's no questions yet. Good. Now, we have been talking about Calico or all the other, what was it, CNI plugins. You remember the common network interface plugins that you can have in Istio, in Kubernetes, sorry. So if you don't do anything, if you don't define anything, it will just use the default network provided by Docker, the overlay bridge network. Now, where it gets interesting is if we use one of those CNI plugins, we can start using, and we've seen that as well in the security part, we can use network policies to isolate namespaces or different elements from namespaces and stuff like that. You cannot do that if you don't use one of those plugins, those network plugins. So Calico is one example, and I chose it to really compare the two of them. So Istio, as I told you, is on layer 7. So it's really on the application level, user space, and the enforcement point is the pod itself, because it's the envoy that enforces those policies. So it's really on the pod level. On the other hand, network plugins like Calico, for example, which are very low level, which are layer 3 or 4, their implementation is at the kernel level. So they're really on the routing tables, and the enforcement point itself is on the node level, so on the worker node level. However, with stuff like that, you can route all different, basically, traffic types that you like. In Istio, you're limited to HTTP 1.2, HTTP 2, gRPC, and TCP. Because it's layer 7, nothing else goes. With one of those, you can route very low level specific traffic around your different VMs, your different nodes. So they don't do the same thing. So a project, or a plugin at this level here, at the network level, is more here to enforce security, like network policies and stuff like that. cluster federation, so that the clusters appear on the same flat VPN network, for example, through a border gateway protocol, stuff like that. And Istio is really more an application level, so very high level routing solution. So they can work together, and they very often do, because Istio really is more high level and helps you address the application concerns. So so I just have here it's some more information on Calico in that case. We won't go into detail. So again, if you take the different strengths, so low level is more universal. Obviously, from protocol level, it's very efficient because it's on the kernel level. It's isolated from the pod, so it's something. It's not. In the beginning, it's not a concept of Kubernetes itself or Kubernetes object, but on Kubernetes nodes. So it's not. It has no notion of what the pod is or what the container is or whatever. Okay, so really good for applying security policies and so on and so forth. And this one is good to apply policies really with operational goals, like service routing, retry circuit breaking, and so on and so forth. I think you get the drift. Won't go much more into detail, but just so you know, the CNI plugins and Istio work perfectly one with another, and usually you need both if you want to implement it. Now, service mesh, bad idea. A mesh network is not always the solution to your challenges. Service meshes are pretty opinionated, as we call it. So they work the way they work. So you have no influence on how they work. Istio has its way of working with the gateways, with the ingress proxies, and so on and so forth, with the virtual services. So either you like it or you don't use it. So it's a bit the credo here. So they're very specific. They can address probably a lot of challenges, perhaps not all, but don't use service meshes if you don't need them. It's complex. Well, it's less and less complex. That's a slide I did 1.5 years ago, where setting up Istio and using it was a bit more complex. You have the control planes, the sidecars, and so on and so forth. Today, with this new architecture, where you just have this Istio daemon that does everything basically, it gets much easier to implement and to update and to maintain and whatever and to administer. So it still adds some complexity because you have a new ingress, you have an egress, you have the rules, you have the control plane, even if it's much easier now. But it adds complexity. So again, if you don't need it, don't use it. Service meshes can be slow. That's less and less true because they have, especially Istio has been largely optimized now. Where it can get slow is if you have a lot of nodes. And I'm not talking about pods here. I'm talking about nodes. But I don't have any customer who today has 700 worker nodes in their clusters. So that's theoretical. There's means afterwards to what we call reflectors to address that. I haven't really looked into that yet because I've never met that problem. But they can introduce a little bit of latency, but usually what you get back from the flexibility and the observability through a Kiali or the dashboards and so on usually makes up for that. But if you have applications that are more or less have to be real time and have to respond really fast to requests, service mesh might be a bad idea. And service meshes are for developers. I should take that one out. It's mainly primarily focused on developers. That's not true anymore. Today it's really, and I should take it out, but it gives me a talking point because in the beginning, it was really something for developers so that I can develop and start routing traffic and so on and so forth. But it has been largely adopted now by the operations faction as well, because they see the benefits of having a service mesh and being able to roll out stuff gradually or in the dark or do canary rollouts and stuff like that. So that's not really true anymore. But still, it's probably in a lot of cases, it makes sense. It's a very good idea. But think about those points and ask yourselves if you really need a service mesh or not. If the answer is, I don't know, then it's probably a bad idea to implement it. Yeah, I mean, the thing is, we developers, and I've been the developer for almost my whole life, we like new and shiny stuff. So we have a tendency to want to implement Kubernetes everywhere. We have a tendency to want to implement service meshes everywhere and operators everywhere and whatever. But and that's probably a good wrap up of the whole series of the 6 installments. Just because it's there and because it's cool and because it's shiny and new doesn't mean that it's always the best solution. And you remember when we talked about microservices, I put on a slide with a guy who made a Google spreadsheet in favor of the monolith. And monoliths still have their, we call that the raison d'être in French. They still have their days ahead, and sometimes they're the best solutions. We talked about that when it makes sense, when it doesn't make sense, microservices. The same goes for operators, the same goes for service meshes, and so on and so forth. Don't implement it just because it's cool. I had a big tendency to do that when I was a bit younger, but be pragmatic and ask yourself, do I need solution XYZ, or are we good with what we have? And one thing that's important to know about Istio as well is that it can integrate VMs into the service mesh as well. So if you have a mixed environment where you're starting migrating to microservices, for example, from a more monolithic application with 4 or 5 VMs that have been running until now, and you transformed, like, so let's say 3 of those 5 VMs into microservices, you can still use a service mesh if it makes sense and integrate those VMs into the service mesh. So you have still the control and the observability into that. Again, that's not something I'm going to talk about in detail here, but again, there's very good documentation on the Istio website. So you have some getting started stuff here. Istio.io is where you want to go. There's a small Istio one-on-one on GitHub from IBM. So I stole some things out of there from my labs. There are some articles. There's the Resiliency and fault tolerance article in here for Istio. So that's something you can have a look at, and reliable application. So that's more for the whole circuit breaker and so topics if you want to have a look at. Good. Questions? Eduardo is typing. So let's give him a second. You have to type faster. But in the meantime, perhaps just introducing, okay. Will it be good to do the lab with my PC? I have an i7, 4 cores and 24 gigs of RAM. Yeah, that should do it. That should do it. I can never tell because the processes are so wildly different. The controllers and the chipsets and whatever. But if you can start your VM with 12, 30 gigs of RAM, it should work. Yeah. Otherwise, get yourself an account in IBM Cloud. Istio telemetry pod is in crash loop back of state. No, that's not a known issue, Zimi. Perhaps wait it out a little bit. Yeah, something and before breaking, that's something very important. So the hands-on, you will be starting that. Though again, you will choose the JTC 10 Istio course, blah blah blah. Then there's the lab. The first lab is installing Istio. So perhaps before breaking, we make the break a little bit longer, but try to start with the installation part of Istio, and then we get back and I do some last slides before going into the labs. But try to start the lab and start Istio because there's a lot of containers to pull, and depending on your internet connectivity, that can take a pretty long time, and sometimes you really have to wait it out. So you might have pods in crash loop back off state. You might have pods that are not ready and whatever, because they all depend on each other. You have the control plane, you have the Kiali, you have Grafana and whatever, and it can take some time to stabilize. sometimes for me, I will launch it as well before going for the break. For me, sometimes it takes like 20, 25 minutes to start up the whole thing. Depends. Okay. With that, I would say we break for 10 minutes to give everybody the time to start it up. And we get back at 4 o'clock. Well, it's a bit more than 10 minutes, but that doesn't matter. Like that you have time to start it up. I have time to start it up. So let's get back at 4 o'clock. So just one last question. So you can start with the lab. I'm just taking the questions. There is a test and delivery pipeline inside the cloud. That's a good question. Which one is that? Oh, in the cloud, when you do the cloud thing. I don't know. I'd have to have a look. I know that you can, in some Kubernetes environments in the IBM Cloud, you can automatically install Istio in there just with a click from the web interface. But try to do it yourself. It's a good exercise to do it yourself and to see how you install it and what happens afterwards, I think. Otherwise, it's completely handled by IBM and hidden by IBM what is happening in the back. Okay. In temp env, how do I start? What is your temp env? Not sure I understand what you mean. Okay, Hendy, I'm still not able to sign up to the free cluster as I haven't have a paid account. Can you take this one, Yuri and or Pascal, please? Oh, in the environment, in the VM, you mean that I provided? Is that the question? Okay, so as I said, let me go back there. Just stop that. So how do you start? You start simply by, where is it here? So you start your VM and you should see something like that. Okay. Then you click on the little terminal sign here down here, which will open a terminal. And then you do ./welcome.sh, which will start up Docker Minikube, the training course and everything. Okay. So this will take already some time. And then once that's running, you have to go through the, and let me share that perhaps for a second. I go back into my, where is it? No, that's not the one. Give me a second. I'm just looking for the training environment. Here it is. Okay, so I show you what you have to do. Let me share. And I have to open. So it takes a little bit of time. Sorry about that. And where is it here? Firefox. Okay, so you start up in your courses. You go to the drop down. You select Istio. Oh, okay. Sorry, I thought you could do without the temp. Yeah, yes, you can do that, but you have to have. Did you already get the VM in the IBM Cloud? The VM, the Kubernetes cluster. You have first to get the Kubernetes cluster in the IBM Cloud. Then you have to follow through. There's a description how you connect to it, how you configure your kube control command to point to the cluster that you've provisioned, and then you could go on with the Istio lab. And I sent that. Give me a sec. I have it on my GitHub. It's in the, where was it? In the training, in standalone Istio, you have the description here, the complete one. So you create your cluster in the IBM Cloud that describes how it's going. And then you have a tab on the IBM Cloud called Access. So it gives you the different commands. I didn't list them because they will be different for you depending on the region where you are. So you did download and install the command line tools. You log into your IBM Cloud account. You set the context for kube control. Then you can verify that you can connect, and then you just run kube control. You should get an input with just one one worker node, and IKS is the IBM Kubernetes service. So you should get that. And then for installing Istio, it's more or less the same as you would do in the personal training environment, but I separated it out so you have it. So on Mac, on Linux, you have to get the Istio control, the command line tool. For Windows, you have to download it here. Then you have to export the path, and then you just say Istio control install. And then don't forget that set profile demo. If you don't set this profile, it will eat up much more space. So with the demo profile, it's absolutely enough to do what we want to do today. If you want to do a more full install, you can set a different profile, but you do it with profile demo. Okay. And if you cannot put it in the path, just go into the directory where you have Istio control and launch it like that. Then you have to label the default namespace with Istio injection enabled. We talked about that. Otherwise, Istio won't be taken into account in the default namespace where we do all our deployments. You can have a look at it, and then you have to wait out that all those different pods are coming up. Okay. So the questions now, there's a lot of questions. You should choose free option. Yes. Okay. We need to upgrade the account to use the free cluster. Yuri, I think you will reply to that, and/or Pascal. I don't know exactly. Normally, you should be able to do a free cluster. That's not a problem. But I thought you could do without VM in the temp env you provided. No, the temp environment that I provided is only the personal training environment. So it's just what you see here. So you can begin your course. It just gives you the course. So you can go through the course and do the course. It's not the environment where you will be executing the whole thing. Okay. And then, okay, is that it tells me to upgrade the account. I have set up my Kubernetes cluster in GCP. It should work in GCP. I don't have the slightest idea. I wasn't able to test it because I don't have a GCP account. Otherwise, I get killed at IBM. Okay, now, yeah, okay, you are there though. So the Minikube IP obviously won't work for this specific one. Yeah, I should correct that in the course if you're using something else. So you can go into Firefox. You will have to determine the IP address of your IBM Cloud account. Sorry, I have a reminder here that's bugging me. Okay, so good. So you have to go. Let me check that out. Cloud.ibm.com. I have a look at mine. I hope it has not expired yet, because even ours will expire. So let me just rapidly check in. Okay. That's our IBM login. But then you should see more or less the same that I'm seeing. Okay, so it's still loading. Okay, let's go into the Kubernetes clusters. That's where your free cluster shows up afterwards. No, I don't have it anymore. So I'd have to create a new one. I think, okay. Let's try that. Free Kubernetes, my cluster free, blah, blah, blah. Create. Okay. Then let me just show you. So that's what you would be doing. It's probably not exactly the same interface. I think for non-IBM users, it's slightly different, but it's more or less the same thing. And that's the different steps I talked about. So you, with this curl here, that will just install the different tools that you need, especially IBM Cloud, the command line tool. Then you will log in. So you get the login here for the IBM Cloud. Then you do IBM Cloud KS, which is Kubernetes Service Cluster Config. So you get the config, and that will change for your cluster because it's another ID. And then you use the current context. So with that, you're good to go. Now, on the overview page, I think you should be able to see the IP address afterwards. The public here service endpoint URL, you should be able to use that. So you'll be doing HTTP, and then the Minikube IP replaces with the public service endpoint and with the still 30,762/product page. So if you can test that once it's up, you can have a look. So I don't have it. It's starting it up. So what I suggest, well, no, sorry, there's some other thing. Istio telemetry is not starting. Does detached describe what makes some sense? Let me have a look. Describe, what does it say? Successfully signed, error failed to start container, no response from the OCI in runtime. Oh, that's a bad one. That means that your container runtime has crashed, Zini. So your Kubernetes, so the runtime, you remember the CRI, the common runtime interface has crashed. So are you on your own machine, Zimi? And what size do you have? Because if you're still on 8 gigs, it won't work. That's exactly stuff like that that will happen. So the virtual lab, and you try to deploy that on the IBM cloud. What's your Kubernetes environment you're using? Okay. Okay, you're using the lab on VirtualBox. Okay. And did you increase the memory of the VM to 12 or 13 gigs? Okay. Well, that's strange. So you know what? Well, it will take some time, but try to go back to the snapshot. Or sorry, other question. Did you go back to clean state from the last labs, or do you still have the other stuff in there from the labs before? I do not see any other Docker container running, so it seems to be clean. Okay. Well, the only thing I can tell you that's typically really it's the plumbing of Kubernetes of Minikube that has crashed. So there's unfortunately not much I can do about that. Have you tried? Well, probably you have, but have you tried deleting the pod and restarting it? Okay. Yeah, you already tried with the other pods are running. You already tried to restart it. It might be that the mixer is just the little thing that makes it go over the limit. So what I suggest will take some time, but go back to the snapshot of your VM, rerun the welcome.sh script, and then retry the installation of Istio. I tested it on VirtualBox and on VMware with 12 gigs, and it did run without any problems. So unfortunately, that's all I can tell you. That's not something that we really can debug. Otherwise, try to give it a little bit more RAM. But you know, that's one thing. Problems like that when you have OCI crashing or something like that, really low level stuff that's hanging up in the VM. It's often a memory or a CPU problem or something like that. And the thing is, we cannot test those VMs on all different configurations possible, even on the Macs. Just on my very late 16-inch MacBook Pro, they use another architecture, CPU architecture than the ones before, and they had huge problems with VirtualBox on it, for example. It crashed all the time, and it killed my machine basically, and I had to restart. So unfortunately, we're not able to test that on every different configuration. Sometimes if stuff like that happens, I usually just throw in a little bit more memory. From the CPU side, you should be okay. Perhaps try to give it a CPU more. Otherwise, get yourself a cluster rapidly on the IBM Cloud and do everything on there as well. Okay. With that, I'd say we break. Yeah, only having issue in this lab. Yeah, I know, and it's exactly the lab that has the biggest resource needs of all the labs that we've done. The other ones were just small stuff. We started 3-4 pods right and left, and that was it. And Istio is pretty resource hungry, to put it mildly. But in if we talk about production or test environments, usually we have way bigger resources than what we have in our VMs here to try it out. Okay, good. Now we're at 4 o'clock, so let's break until 4:10, and then I do just a wrap up slide thingy, and I'll see if there's some more questions arriving in the meantime. We answer the questions, and you can go on with the lab. Start with the lab already if you like, if you've already taken your break. Otherwise, we'll reconvene at 4:10.
Nick, short question.
Yes.
For the free cluster on the IBM Cloud, this works from the specs point of view.
Yes, it works. I've done it. Okay. I've done it. The thing is that with the VM, obviously you need a little bit more because you have the overhead of your machine running, then you have the VM running on your machine, and then you have Kubernetes running on the VM running on your host. So it's a lot of stuff to take in. But usually Kubernetes Istio doesn't take up that much memory and stuff. But if you do it on your own machine, you need a little bit more firepower. But the cluster on the cloud, at least for me, it worked without any problem, and I got the free one the same as you did.
Perfect, thank you.
Okay. Oh, there's a question. Yes. Why do we need to do this step 7 Istio installation, patch the node port? Because when you deploy Istio, the ingress, the HTTP, so the non-secure port, and the others as well, by the way, get assigned the node port, which normally is determined randomly. So you won't get the same port number all the time. And I didn't want you to have to go in, look at the service, determine the node port, and then use this node port all the time. This patching just sets the node port to this 3762. Like that, we all have the same node port, and we can use the same for everybody. Very stupid, but it just helps to standardize the labs a little bit. Okay, so I'm off until 10 past, and we'll be back then.